Right, for tonight, it's quite a short note, but a fairly long video. So the thing that I need you to get written down in your books is the very first things that you see on this slide in front of you. And then after that, I'll let you know when you can stop copying. We'll go through a very similar thing, but we'll do it in class together where I can help you. What I need you to see tonight is just an introduction. All right, so let's start with the law of reflection. Let's consider first of all a straight mirror or a plane mirror. Plane as in P-L-A-N-E. So a flat plane. The light that strikes that mirror is called an incident ray. The incident ray is the ray of light that arrives at the mirror's surface, and you can see that from the direction of the arrowhead. The incident ray will strike the mirror at any particular position along the face of the mirror. It doesn't matter where. Wherever it strikes the mirror, we can imagine a line called the normal that is 90 degrees to the mirror. Okay, so it's perpendicular to the mirror. The reflected ray is the actual light ray that we see bouncing off the face of the mirror. Okay, so the incident ray is the ray that strikes the mirror. The normal is any imaginary line that runs 90 degrees to the mirror. And the reflected ray is the light ray that we see bouncing back off the mirror. The angle of incidence is the angle between the incident ray and the normal line. Remember that normal line is an imaginary line that we're drawing in our heads. Also, the angle of reflection is the angle between the normal ray and the reflected ray. Okay, so you've got some definitions here. And I actually would like you to write these definitions in your notes. So incident ray is the light ray that strikes the mirror's surface. The normal is an imaginary line that runs 90 degrees to the face of the mirror. The reflected ray is the light ray that bounces off the face of the mirror. The angle of incidence is the angle between the incident ray and the normal. And the angle of reflection is the line between the normal and the reflected ray, the angle between the normal and the reflected ray. All right, the law of reflection is quite simple. The angle of incidence must equal the angle of reflection, and that's it. That's the law. Angle of incidence must equal the angle of reflection. What's important to understand is that the angle of incidence is not measured between the face of the mirror and the incident ray. That's the most common mistake I see. The angle of incidence is measured between the incident ray and the normal. So we always measure from the normal. All right, so that's what I need you to write down. I want you to copy down this diagram, but I also want you to write down definitions for the incident ray, the normal, the reflected ray, the angle of incidence, and the angle of reflection. And that's all you'll need to write for tonight. Let's look at how an image forms in a plane mirror or in a straight mirror. So there are an unlimited number, an infinite number of light rays that leave the object and strike the surface of the mirror. In this diagram, we've only shown 2, and we've done that just to keep it simple. So the first step is to draw normal lines where each incident ray strikes the face of the mirror. So one normal line goes in here, and the other normal line goes in here. Okay, so that's where the incident rays strike the normal. Now remember, you don't need to copy this down. You're only watching to see what happens. Step number 2 is to draw the reflected ray, but make sure that you obey the law of reflection. So the law of reflection, again, is that the angle of incidence must equal the angle of reflection. And those angles are measured against the normal, not against the mirror themselves. All right? So our reflected rays are found here and here. Okay? Notice that the angle between the incident ray and the normal is the same as the angle between the reflected ray and the normal in both cases. Step number 3 relies on your brain not understanding that light can be reflected. Okay, so even though you understand that, the very primitive parts of your brain that are responsible for processing visual cues, they don't understand that. And so the brain forms an image of this pencil back behind the mirror where it can't actually be. So step number 3 is drawing where your brain thinks the light came from. Okay, so to do that, we extend the reflected rays behind the mirror, and we just keep extending them until they meet. So there's one, there's the other, and the point at which they meet is the tip of the pencil. And that's because with the incident rays, both of the incident rays that we have drawn left the tip of the pencil before they struck the surface of the mirror. So these two light rays are carrying information to you about the tip of the pencil. And so this is where the image forms. We could go through exactly the same exercise with an infinite number of reflected rays leaving from our original pencil. We only chose 2. The distances are the same length. So the distance between the actual pencil and the face of the mirror is the same as the difference between the face of the mirror and the image of the pencil. Now, you know that just through experience. You know that from looking at your own image in the mirror, you appear to stand as far, your image appears to stand as far back from the face of the mirror as you do. And if you approach the mirror, so does your image. All right? The distances are the same length. And by studying these reflected rays extended behind the mirror, we can see why those distances come out to be the same length, all obeying the law of reflection. We'll talk about this again when we see each other in class tomorrow.